theta decreases from 1 to 0, as we can see here, and it remains positive. And this is something we can also see from the first quadrant here, that as long as line segment OP remains in the first quadrant, its projection on both the x and y axis would be positive. Therefore, sine theta increases from 0 to 1 and also remains positive. And similarly, we can see that as theta increases from pi by 2 to pi, cos theta decreases from 0 to minus 1 and is negative. And sine theta decreases from 1 to 0 but is positive because the projection on the y-axis is positive. And similarly, as theta increases from pi to 3 pi by 2, cos theta increases from minus 1 to 0 but remains negative because the projection on the x-axis is negative. And sine theta decreases from 0 to minus 1 and is also negative. And as theta increases from 3 pi by 2 to 2 pi, cos theta increases and becomes positive, and sine theta also increases but remains negative. As in the fourth quadrant, projection on the y-axis is on the negative side. Now we can also show this trend for other trigonometric ratios such as tan theta, sec theta, and cosec theta. Now tan theta is sine theta by cos theta. Therefore, for 0 radians, tan theta is 0. For pi by 2, it will be not defined because anything divided by 0 is not defined. And for pi radians, it will again be 0. 0 by minus 1 is 0. For 3 pi by 2, it's again not defined. And for 2 pi radians, it's back to 0. And because sec theta is 1 by cos theta, therefore for 0 radians it is 1. For pi by 2 it's not defined. For pi it is minus 1. For 3 pi by 2, sec theta is again not defined because 1 divided by 0 is not defined. And for 2 pi it is back to 1. Now cosec theta is 1 by sine theta. Therefore for 0 radians it is not defined. For pi by 2 it is 1. For pi it is again not defined. For 3 pi by 2 it's minus 1. And for 2 pi it's not defined. Now let us see how these ratios behave as we move through the quadrants. Now as theta increases from 0 to pi by 2 in quadrant 1, tan theta changes from 0 to not defined. But because cos theta is positive and sine theta is positive, we can say that tan theta is positive. And therefore, we can say that it actually increases. It increases from 0 to something close to infinity. So as theta is in the first quadrant and moves close to pi by 2, tan theta becomes a very large number, close to positive infinity. And as theta increases from pi by 2 to pi in the second quadrant, tan theta changes from not defined to 0. But this time it is negative because we can see that cos theta is negative whereas sine theta is positive. So the ratio would be negative. And because tan theta is negative and it moves from not defined to 0, so it's obvious that it is increasing towards 0 from negative values. And therefore when theta is in the second quadrant and close to pi by 2, tan theta is a large negative number which is close to minus infinity. So we can see that as theta crosses over from quadrant 1 to quadrant 2 across a value of pi by 2, the tan theta suddenly switches from a large positive number to a large negative number. And likewise, as theta increases from pi to 3 pi by 2, tan theta changes from 0 to nd, not defined. And this time it is positive because we can see that both cos theta and sine theta are positive. So their ratio would be positive. and therefore tan theta increases from 0 to positive direction. And therefore we can say that as theta gets close to 3 pi by 2 and it is still in the third quadrant, tan theta becomes a very large number, close to positive infinity. And finally, when theta increases from 3 pi by 2 to 2 pi, tan theta goes from not defined to 0, and this time it again becomes negative because cos theta is positive and sin theta is negative, and therefore we can say that it is moving towards 0 from the negative side, and therefore when theta is in the fourth quadrant and close to 3 pi by 2, tan theta is a very large negative number, close to minus infinity, and therefore we see that once again, as theta crosses over from the third to the fourth quadrant, as it passes through 3 pi by 2, tan theta switches suddenly from a very large positive number to a large negative number. Okay, so now because we know that the value of theta is equivalent after every 2 pi interval, therefore we can say that these patterns would repeat after intervals of 2 pi, both on the positive and the negative side. That is, values of theta beyond 2 pi and below 0. And we can also see that the values of cosine and sine theta repeat after every 2 pi interval, as we can see that their values are same for 0 and 2 pi radians for both sine and cosine theta. But in case of tan theta, we see that its value repeats after intervals of pi radians. Let us now see what are the domains and ranges of each of these trigonometric ratios. And let us write them in the small space that we have here. Let us first look at cos theta and sin theta here. First, we see that cos theta and sin theta are defined for all possible values of theta, both from 0 to 2 pi and beyond these limits as well. Therefore, we can say that their domains are all possible values of theta, which is the entire set of real numbers. And their ranges are all possible values that cos theta and sin theta themselves can take. And we can see from here that cos theta could vary from a minimum of -1 to a maximum of 1. And likewise, sin theta too could vary from a minimum of -1 to a maximum value of 1. And this we can see also in this unit circle, that cos theta is basically the projection of OP on the x-axis, which could vary from a minimum of -1, which is when P coincides with C, to a maximum of +1, which is when P coincides with A. And likewise, sin theta could vary from -1, which is when P coincides with D, the projection on the y-axis, to a value of +1 when P coincides with B. Therefore, we can write their range as the closed set -1 to 1 for both cos theta and sin theta. Now let us look at tan theta. Now we see here that tan theta is not defined for certain values of theta, for example pi by 2 and 3 pi by 2. And even beyond 2 pi and even below 0, it would not be valid for certain values of theta. Now, is there some pattern here? If you look at this unit circle here, you would notice that whenever point P coincides with point B or point D, we have cos theta is equal to 0, and that's when tan theta is not defined, because cos theta appears in the denominator of the tan theta ratio. Now, if you notice the values that theta would take when P coincides with B or D, we see that theta is an odd integral multiple of pi by 2. For example, when P is at B, theta could be pi by 2, 5 pi by 2, 9 pi by 2, or even on the negative side, -3 pi by 2, which is the angle from here to here, and -7 pi by 2, and so on. And when P is at D, theta could be equal to 3 pi by 2, 7 pi by 2, 11 pi by 2, and on the negative side, -pi by 2, -5